Hi, welcome Cisco students. I want to take a few moments to go through Packet Tracer 2.7.1. That's in the third course in the Cisco program. That's Enterprise Networking, Security, and Automation. OSPF is a dynamic link state routing protocol. It's a way to dynamically track all the routes in a network. OSPF uses the concept of areas to keep track of all the routes within a network. And so what we're just going to do is kind of walk through this piece by piece here. Let's just take a look at what we have. We have a network. Actually, if you include all LANs and point-to-points, it's actually several networks, but we're going to group it as one overall network. In the headquarters area over here with 3 routers and 3 LANs. And over on this side, we have a data services area with 3 routers connected with a switch, and there's 2 LANs, 2 switch networks over here as well. We're also, this BC1 router, this is an edge router. If you notice, it is connected to an ISP cloud, so this represents our internet access. And we have an internet server over here, which is we'll use in the packet tracer to test our connectivity. So the first thing it requires us to do is it says use process ID 10 for OSPF activations on all routers. And I'm actually going to do this in steps. I'm going to do these 3 routers here. First, okay, so that's done for these 3. We'll have to do that for these other 3 as well. But right now we're going to concentrate on the headquarters section, because this packet tracer has kind of divided this up. There's 2 different ways that you can enable OSPF on routers, and it is having us do method on the headquarters section and just doing the other method on the data services section of this network. So I'm just going to split that up so we can see that in action a little bit better. So activate the OSPF using network statements and inverse masks on the routers in the headquarters network. So that's this over here. And if you should know what a wildcard is. A wildcard is another way to represent the subnet mask of a network. It's the inverse of the subnet mask. Another way of looking at it is in a subnet mask, you would take the values over the 1 bits. If you look at a subnet mask, in a wildcard, you're taking the value over the 0 bits, so the network bits. Maybe I'll show you that really quick. Let's go over here. Oh, pardon my drawing. You're going to have to go. Don't be an imposter. So let's say you've got a /24, prefix network. Obviously, that's 24 ones, so that's all ones in the first hectet, all ones in the second hectet, all ones in the third hectet, and then zeros on the last hectet, octet. You know what I mean? So this would be, in the subnet mask, would be 255.255.255.0. However, for a wildcard, you're taking the value over these 0 bits. So a wildcard for this would be 0.0.0.255. One more quick example, and then we'll get back to the packet tracer. Let's say you have a /30 network. That's 31. So I'm just going to write the last octet. We have 24 ones to the left, 25, 26, 27, 28, 29, 30, and 2 zeros. Obviously, if you're looking at the subnet mask, you're taking the values over the ones, and this subnet mask for /30 will be 255, 255, 255.252. However, for the wildcard, you're just counting the values over the zeros. So you have 0.0.0.3. So /30 wildcard would be 0.0.0.3. If you don't have that concept down, maybe practice it a bit, because you will need it in this course, not just for OSPF, but also when you get into some other topics in this course as well, like action control lists, for instance. So back to the packet tracer. So it wants us to activate OSPF using network statements and inverse masks in the routers in the headquarters network. So what we're basically doing here is we're defining what networks we're going to advertise to the other routers in the group, in the area, I should say. So P2P1 is what we're on right now. There are 3 networks connected to that. They're all point-to-points. So let's start with that. We'll put it right there. You can see the networks. So network, we'll start with this one over here first, 10.0.0.0, and now we have to put the wildcard in. We just did that one. That's /30 is 0.0.0.3. And then define the area, and area 0 is like the default backbone area, but in this case, it's actually defined what area it is right here in the packet tracer. Need that space though. And let's add the other 2 networks that are connected to that router. It's the same subnet mask for each, so I'm just going to up arrow it a little faster. Now let's go to P2P2. This has 4 networks connected. And we're going to start to see some adjacencies forming here pretty soon, I bet. There's one right there, just popped in. Now let's get the other 2 networks. Now this is a /24, so the inverse, the wildcard would be 0.0.0.255. And for P2P3, we have network 10.0.0.8. Formed another adjacency, Okay. So we've just activated on these 3 routers, and they are going to be communicating with each other. Now it says activate OSPF by configuring the interfaces of the network devices in the data service network where required. So in this one, remember we still got to assign the process ID for these. So let's get that done first. Let's take a look at what interfaces we have on this router. You see 3 networks. Now this network here is connected to the ISP. So do we need to set up OSPF on this? We don't. Typically, unless your ISP specifies it. Normally that would not be the case. So what active interfaces do we have here? We have gigabit 000 and serial 010. But we don't have to worry about serial 011. That is the uplink to the internet. So we're just going to worry about serial 010 and the gigabit port. So I'll start with the serial port since that's connected to P2P1. Now in this method, all you do is go to the interface, type in IP OSPF, process ID, which is 10, and then specify the area. You don't have to know the wildcard in this case. And notice it just picked up the adjacency this automatically, so it's already communicating with this router over here and getting all its routes. So go to interface gigabit 000. Same command. Again, I don't need, when I do this method, I don't need the wildcard. I don't need to specify the networks. Just activate the interface for OSPF. Minimize that. In this router, it's only using the gigabit Ethernet ports, and I know that that's 000 and 001. So this method has some advantages. You don't have to calculate the wildcard for one. Okay, so these first 2 items are done. Now we're going to go on to Jason is forming there. We're going to go on to each of these. See, configure router IDs on the multi-access network routers as follows. Okay, so multi-access, we're talking about this right here. These are all connected to a switch. That's a multi-access network. So BC1, we're going to set up a router ID of 6.6.6.6. It's just router ID. BC3 is 4.4.4.4. Nope. And BC2 is 5.5.5.5. Okay, so this is now done. So we've done all of this. So next is to configure OSPF so routing updates are not sent into networks where they are not required. When you read about OSPF in modules 1 and 2, especially module 1, where they talk about they talk less about the configuration, more about the concepts of OSPF. It explains how OSPF works. So basically, all these routers, they communicate with each other using multicast. They send out OSPF packets to basically keep up to date with all the routes and to communicate routes and link states and all that stuff. Well, routers, multicast, it works a lot like broadcast. It sends out these packets out all interfaces on a router, and multicasting works in a way that if it is a message that's not meant for a device, the device will ignore it. But we don't really want all that OSPF header traffic, all those OSPF packets going out these local area networks. No router here to communicate with, so it's a waste of resource to send all that OSPF headers out these. So what we're going to do is we're going to make these passive interfaces. We'll start over here. So we're already on the router, so passive interface gigabit 0/0/0 and 0/0/1. So now no OSPF headers are going to be going out this. On P2P3 we'll do the same thing. And that is also a gigabit port. I bet it's 0/0/0. Just to make sure, I'm going to take a look. Yeah, 0/0/0/0/1 is not assigned. We could set this to passive, just thinking ahead. If somebody plugged in a switch network on this, it would automatically be passive automatically, but it's not absolutely necessary. Now this one, however, we don't want to turn off. We don't want to make this gigabit Ethernet port. We don't want to make this link passive. This has to communicate with other routers. We just want to make this one passive. So this one I need to double check what this interface is. And that's 0/0/0. This is probably 0/0/0 as well, but I'll double check it just to be on the safe side. Yep. See that is 0/0/0 as well. Okay, now on this router, we don't actually have to set this serial link to the ISP as passive. However, the packet tracer will not give you full credit unless you do. And there's a reason why you might want to put this as a passive link, even though it doesn't have OSPF enabled on it. If by some accident, a junior network administrator came in and assumed that this should be OSPF and enabled OSPF, if this was not set to passive, then OSPF headers would be going out to the uplink to the ISP, and that could have potential security ramifications. So it's a good idea on a link, even if it is not OSPF enabled, to set it to passive anyway. And I believe that's serial 011. It is. So we're going to set that one to be passive as well. Now we've done up to this step. Now we got to configure router BC1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. And I forgot to mention that there is a reason why I went and enabled this one first. Best practice, if you are setting up OSPF and you know which router you want to be the designated router, you should set up OSPF on that router first. It will automatically, the first one you set up will be the designated router by default, because when you set it up for the first time, it looks for other routers that it could elect as the designated router. It won't see any others because there won't be any other routers online, so it'll elect itself as the designated router. But over time, the designated router, especially if these get rebooted for some reason, it could elect a different designated router. So instructions are basically saying we want BC1 to be the designated router. And so we're going to set the priority on the interface. Let's see. That would be gigabit 000. We want that to be the highest priority. So let's go into IP OSPF priority, and it specifically says the highest priority available. And if you hit question mark, it'll give you the options. It's from 0 to 255. The larger number is the higher priority. So we'll choose the highest available priority, which is 255. So that's done. This basically ensures that if these routers get rebooted, BC1 will be elected the designated router. Let's see, we just did that one. Configure a default route to the ISP cloud using the exit interface command argument. Remember, because module 14 or 15 of the second course in the program talks a little bit about static routing, default routing. Anytime you have access to the internet, you really need a default route. So we'll go into the configuration. We're going to set the default route. And it's a point-to-point network, so we can use the exit interface. It's more efficient. And this was serial 011, as I recall. Yep. Packet tracer is going to yell at us, but this is a point-to-point interface, so that's perfectly fine. Now, just because we set up a default interface on BC1 doesn't mean automatically it's going to be propagated out. That's a static route. It doesn't. We need to tell it to propagate that out to other routers. That's what the next step is. Automatically distribute the default route to all routers on the network. And if we go to router OSPF 10, And there's, in the real world, there's a lot of options under default information, but in Packet Tracer, there's only one, and that is originate. And this basically tells it to automatically distribute the default route to all routers on the network. And we're coming up on the end here. Configure the OSPF router so that the gigabit Ethernet interface costs will be 10 and the fast Ethernet cost will be 100. I'm going to tell you, this is a typo. So if you're doing this as it says, you're not going to get your points scored for you. This, based on the scoring that this packet tracer gives you for the commands that it's expecting to see, this should say configure the OSPF router so that the gigabit Ethernet interface cost will be 1 and the fast Ethernet cost will be 100. We're basically saying that a gigabit interface is a cost of 1. And we can set that. It's auto cost, reference band, and whatever the reference band you want to be. So in this case, we want it to be the gigabit Ethernet to be a cost of 1. So we specify the reference bandwidth to be 1,000. If we wanted the reference to be a fast Ethernet connection, then we would say auto cost reference bandwidth 100. But in this case, we want it to be 1,000. Now, if you were to do what the instructions say to do and say that the gigabit Ethernet cost will be 10, that basically means you're setting the reference to be the 1. A 10 gigabit Ethernet connection would be a reference of 1. In that case, you would set the reference bandwidth to be 10,000. You're basically saying a 10 gigabit connection has a cost of 1. Like I said, this, however, is a typo. So keep that in mind when you're doing this. Okay, and I think we just have a couple more things to do. Configure the OSPF cost value of P2P1 interface serial 011 to 50. Let's take a look at that. OSPF cost value of P2P1 interface serial 011. Okay, so it's basically setting this to have a cost of 50. So prioritizing traffic to go this way for some reason. Just gives us something to do, I think. I don't think there's a logical reason to go one way or the other. So go into configuration again. Interface serial 011, right? And once you're here, you can set IP OSPF cost of 50. And that's done. And the last step, they want us to configure the hello and dead timer values on the interfaces that connect the headquarters to the data services to be twice the default value. So what we're basically doing there is we're throttling back the amount of traffic, of overhead traffic that's occurring between these two routers. And this could happen if you had a, let's say this connection is maybe like a T1, or maybe it's a T3, and maybe it's 45 megabits or so. You know, that's fast enough, but it's not as fast as, you know, a lot of the links that are in here. A lot of these are probably, you know, 100 megabits connections or faster, or gigabit. So if this was a slower link, you might want to throttle back the amount of OSPF headers that are going back and forth. And that's what this is basically telling us to do. We're throttling back so that these hello and dead timer values, these OSPF packets are not going to go out as often. They go out half as often as normal. We need to do this on both ends of the interface. And that's this network here, which is serial 020. It's IP OSPF hello interval, and the default for the hello interval is 10, so we'll double that to 20 seconds. And the default for dead interval is, let's see, I think it's 40. Yep, so it's 40, so we'll bump that up to 80. I'm going to do that on this side as well. That's serial 010, I believe. Yep. And there, ta-da, we're all done with Packet Tracer 271. All right, if you have any questions, feel free to leave a comment below or reach me, via email, or you know how to reach me. I hope this helps. You have a good day.